Okay, we're gonna look at grade 11 functions, guys. Grade 11 functions. I think grade 11 functions are, yeah. Okay, so we're gonna look at grade 11 functions. Yeah, I think that's basically what we'll be doing. We'll see how far we can go with them. Talk about some conceptual underpinnings of the functions, and then see if we can be able to establish some things. All right, I'll try and recap through the functions for grade 11, all of them, but also check out grade 10 and what happened there, so that we can continue on with the same sort of like understanding, the understanding that we ought to have at this stage. Okay, so I don't know if Orally is here. Don't know. Maybe she is, maybe she isn't. Because yeah, that was like a special request from her that functions be done. Present. Okay, that's you. I think that's you alone on this live session. That's fine now. Okay, let's look at each respective function so that we can appreciate. I don't know if orally you were actually present in my first presentation of functions that I did on TikTok, though. Didn't do it here on this platform, but I uploaded the video on TikTok so that people can actually have the chance of watching it again. So I don't know if you were in any way exposed to that video in any way, but if you weren't, I guess it's not a train smash. We can always I think I'll probably be doing a bit more even today anyways, if we look at what I'm intending to do for grade 11 functions. Oh, you did watch it? Okay, nice. Okay, nice. Hopefully you can see very well, no problem. Okay, so let's look at each respective function and try and make sure that we are on the same page where it comes to these functions. So we have our linear function, right? Linear function. Yeah. Now, linear function is quite straightforward. We have the form y is equal to ax plus q. Okay. We know that when a is greater than 0, this is kind of like how we expect things to be. If a is less than 0, this is the shape and how we expect it to be. If a is equal to 0, this is the horizontal straight line that we expect it to be. And if a is undefined, then this is the way we expect our function to be, a vertical line. And here's a few things to mention. Y is equal to q, x is equal, so let me just remove this q because it may give people the idea that, let me just say, yeah, so in other words, this means that some constant, which is an element of real numbers, okay, yeah, whatever that is, some constant that is an element of real numbers, okay, that is the form. This we refer to as an increasing function. This we refer to as a decreasing function. Okay. Now, a few more additional things about a straight line is that there are no axes of symmetry. Okay, there are no axes of symmetry. I just wanna there's no axis of symmetry. There are no asymptotes. And I don't know if you know what an axis of symmetry. An axis of symmetry is a lateral line that basically, it's a line that cuts the graph into half. Okay, so that doesn't exist for a straight line. Asymptotes are simply boundary lines. It's like areas where the function cannot exist. It's like where the function cannot exist. So that's not there for a straight line. We don't have no asymptotes, so there's no boundary lines. Okay. Then another thing is that if the straight line is unrestricted, then the domain, which domain means the possible x values where our function exists, we know that our domain will always be x is an element of real numbers if the function is unrestricted. Okay, so in other words, if a is positive and the function is an increasing function, our domain here is going to be x is an element of real numbers. In other words, the function will exist everywhere from left to right. These arrows are a typical indication that the function exists everywhere from left to right. Horizontally, from left to right, the function will exist everywhere. If the function is a decreasing function, the domain of that function as well is x is an element of real numbers. In other words, the function will exist everywhere from left to right horizontally. Okay. Then if it is a horizontal line and y is equal to some constant value, then the domain as well will be x is an element of real numbers, because the function will exist everywhere from left to right horizontally. And then if a is undefined, in other words, the function is x is equal to some constant, then the domain of that function will be equal to the value of that constant. Because remember, for x, if it's a vertical line, for x it will only exist for that x value alone. So that is why I'm saying to you guys that if the straight line is unrestricted, the domain, or in other words, the possible x values where the function will exist will be x is an element of R. All right. So that will apply for when a is positive and the function is unrestricted, when a is negative, where the function is unrestricted, where a is equal to 0, or the gradient is equal to 0, the function is a horizontal line, the domain will be x is an element of real numbers. The function will exist everywhere for x. Okay. But when it is a vertical line, meaning it is restricted in this way as far as from left to right, the function from left to right does not exist everywhere. It only exists for this x value alone, right? So if this was the line x is equal to 3, it would mean that the domain of that particular function is x is equal to 3 alone. It cannot be x as an element of real numbers. So Usually teachers make the mistake of saying to a classroom that the domain of any straight line is x is an element of real numbers. In other words, the function exists everywhere. But then they don't take into consideration that sometimes a function is restricted. Okay, I'm just going to give you another example of what I mean by a function that is restricted. Here is an increasing function. Okay, but here's the thing about it. Where x is equal to 3 and where x is equal to -4, it seems like the function has been restricted. Meaning, in other words, the function does not continue, but it stops there. There is an open dot, sort of like a boundary point. And then here, there is a shaded dot, somewhat of a boundary point. In other words, this function does not move any further from this -4 x value here. So there's this restriction. So the domain here, you wouldn't say here x is an element of a real number. The reality of the matter is the function is not included at 3. So it exists everywhere before this +3. It exists. You can see there it is for x 0. There it is. There it is. There it is. There. There it is. There it is. Okay. And then at -4, it exists as well because it is included. So we would say for the domain, we would say x is an element, close bracket, because this is -4 and it is shaded. So it's -4 to what? To 3, open bracket for 3. You see? So that's why I'm saying we need to always consider the situation of the particular function that we are given in order to state the domain. Remember, the word domain simply means the possible x values where the function exists, where it is available, where it actually is drawn. So therefore here it is drawn only from this x value, which is -4, all the way to +3, and at +3 it's not even included because there's an open dot. You may remember this shaded and open dot from when we did inequalities. So now there is practical application in finding the domain, where we write the interval of the domain where the function exists as being -4 where -4 is included, to 3 where 3 is not included. So that would be our domain. So please guys, let's take note. I'm going to repeat this again. For the domain of a straight line function that is unrestricted, x is an element of R. For the domain of a straight line that has that is decreasing, where a is less than 0, that is unrestricted, the domain is also x is an element of R. For the domain of a function where the gradient is equal to 0 or a is equal to 0, it's a horizontal line, the domain is also x is an element of R. And so it goes. Where the straight line is vertical, that means that the function is only restricted for the single x value, which is that constant value. So we'd say x is equal to, when you're writing the domain, as that value of c. And then last but not least, if the straight line is increasing but it is restricted, guys, then you have to consider the shaded or the openness. If it was open on both sides, we'd say open brackets on both sides. But because this one is shaded, we say square bracket. That one is open, we use the open bracket. Okay, so that's just a little bit about that. Then we have something else that we refer to as a range. Range is the possible, not x values this time, the possible y values where the function exists. Okay, the possible y values where the function exists. So possible y values where the function exists. Okay, we don't look at the range as we did the domain, meaning from left to right. We look at the range from the bottom, because that's the most negative value when we look at the Cartesian plane, to the top. Started from the bottom, now we here. Started from the bottom, now we here. Start from the bottom, then we go up. So from the bottom up. So let's think about this particular function a little bit more. Let's say the value here was -2 and the value there was +4. Now we need to write the range of the function. But before we look at this restricted function, let's go first look at the unrestricted function of a straight line. What would we say is the range of this function where a, meaning the gradient, is positive and the function is unrestricted? Okay, does anyone know in the comment section? Let me see if anyone knows in the comment section so that I don't speak alone. What would be the range of an unrestricted increasing function? Unrestricted increasing function. What would be the range? So that I don't play this game of speaking alone. An unrestricted increasing function. What would be the range of the unrestricted increasing function? Anyone know? Unrestricted increasing function. What would be the range of the unrestricted increasing function? Range, anyone? Thank you, Orally. Love you. Man, you rock. You're a rock star. Y is an element of real numbers. Okay, nice. Y is an element of real numbers. Okay, there we go. Y is an element of real numbers. True. Okay, so if a is positive, it's an unrestricted increasing function. Y is an element of R. If a is negative, it's an unrestricted decreasing function. The range would also be y is an element of real numbers. If it's a horizontal line, okay, and it's an unrestricted function, we can see, guys, that here y is only from the bottom to the top. This only exists for y is equal to that constant value. So here we wouldn't say y is an element of real numbers for a horizontal line. If we are looking at the range, we would say y is equal to that particular constant value for a horizontal line. That's very important to note. But interestingly enough, for the vertical line, from the bottom to the top, we would say y is an element of real numbers. So I hope you guys can see the difference. When we were looking at the domain, when we looked at this function, we said it exists for all real values. But then when we looked at the vertical line, when we were looking at the domain, we said x is equal to the constant that we are referring to. Then we were talking about domain. But now vice versa is true. When we look talking about the range for this particular line, we say y is equal to that constant value. That is the range. Because for y, this function only exists at that specific value of y. But when you look at the range of a vertical straight line, we're looking from the bottom, now we're here, bottom, now we're here, bottom, now we're here. We're looking at the bottom, now we're here, top to bottom. So therefore it would be y is an element of real numbers. Okay, hopefully that is very clear for you now, that case, and that's very important for our domain and our range. Okay, then of course we move on to the next big and better thing when it comes to our straight line function, and that is sketching. Okay, and in that video that I did, right, when I was teaching on TikTok, I said that if our linear function, like this one, is a straight line function where the constant is not 0, then we use the dual intercept method to sketch. Dual what? Intercept method to sketch. And what is the dual intercept method? Two things. the y-intercept, which means we let x be equal to 0. And when we do that, we are quickly able to find our y-intercept, where the graph cuts the y-axis. There it is. Those are the coordinates of the y-intercept. Y is equal to 6, that is our y-intercept. 2, the x-intercept, we let y be equal to 0 there. 0 is equal to 3x plus 6. We transpose, we divide, we get x is equal to negative 2. When we have these 2 points, we go ahead and we identify them on the Cartesian plane. 0 and 6 here somewhere, negative 2 and 0 here somewhere. And what's beautiful is that we were looking at a here, the coefficient of x, and already we were expecting that the shape would be somewhat like this, just from our beginning, because when a is positive, we're expecting an increasing function. The y-intercept is going to be 6, and truly it is. Then we take a ruler and we connect, and then we label, and then we leave it at that. That's how we sketch. When the y-intercept is not 0, where the q value is not 0, we use the dual intercept method. But when we know we want to sketch, and it's obvious here that we do not have what? We do not have the q value is equal to 0. Then what do? We use the table method. Okay, and our calculator okay, just hang on guys, I need to grab water for this boy. Maybe you guys can sketch this function for me whilst I'm gone so that I can come back. I'm coming. Okay, sorry about that. Sorry about that. Yeah, just something was calling. So yeah, like I was explaining, that if ever guys the q value is 0, then that is an obvious invitation to us that, guys, okay, we need to actually make sure we use the table method. All right, Now, what's nice is that this trusted, beautiful calculator that we have here does all of these things for free. Okay, it does all of these things for free, right? And all that we have to do is simply make sure that you go to mode, you put on your calculator first, you go to mode, you press 3 for table, and that's what it does. It says f of x is equal to, remember f of x means y, right? Then you can be able to write 3, you press 3 from the calculator, you press alpha so that you can select the x that's red. And then there it is, you get 3x. You see that? Then you can say equal. G of x would be a second function if you had one. Then you can start. Okay, I love using small values, so let's say -2, right? And then let's proceed to, on the other side, we can end at 2. Step will be 1. And there, that's what it does. It provides for us the tabulated form. All right, and what I usually like is that you can just simply do this. Okay, what you want when you sketch, guys, is just simply, you want to see what's happening. So if x is -2, for instance, y is -6. So -6 is somewhere here. So where those two meet is there. Okay, you know at some point that this graph passes at the origin, and then it would be nice to go and look for 2 and 6. There it is, 2 and 6. I mean, where x, because you checked where x is -2, so it would be nice to just check on the other side for the positive value where x is 2, so that you can go and check what is the corresponding y value when x is 2, y is 6. So you go there, you check 6, you see where they meet. There it is. All right, yeah, and then you just take your ruler, you connect those 3. You see that straight line. Okay, and then you slightly exceed that place where your dot at the end is, because this is not a restricted function, it's an unrestricted function. But what you did is you used the table method. Why? Because if you use the dual intercept method, you are going to let x be equal to 0. 3 times 0 is 0. So what you would get is 0 and 0. You would get this origin, okay, which is an obvious. But the thing is, you don't need only the origin to sketch the function. So because you know that if you let x be equal to 0, you're going to get y is equal to 0. If you let y be equal to 0, you're going to get x that's equal to 0. It's not sufficient. So our table method assists us to be able to find what are the other points on the positive side and what the other points are on the negative side. So what I usually suggest to learners is that you can at least write one x value that's negative and one x value that's positive, and utilize that to find a corresponding y value, and then you can just connect that with the origin point with that other point, and then at least the graph is complete and finished when you sketch it in that way. So I repeat again one more time that whenever you are given a function where q is not 0, you use the dual intercept method. You let yx be equal to 0, you find the point. You let y be equal to 0, you find the point, and then you ensure that you mark those points on your function, on your Cartesian plane, and then you sketch the graph. But if the value of q is equal to 0, we just use the table method, guys. It makes life easy. It shortens things for us and makes sure that we don't complicate our lives more than they already are. Okay, I hope that's clear. So if you were to then explain to me what is the range and the domain for this function, obviously it would be very easy to explain the range and the domain, right? Because the range for this function, this one, let's look at this function, the one that we drew using the dual intercept method. What would be the domain for this function? What is the domain of this function? So in other words, where is the function? Where does it exist from left to right? Okay, hopefully you guys see where it exists from left to right. What would be the range of the function? where does it exist from the bottom up? Okay, so hopefully you will see where it exists from the bottom up, the domain and the range. Okay, because domain and the range are things that we need to be constantly able to answer whenever we are asked. So the domain of this function, x is an element of real numbers. What about the range of the function? Y is an element of real numbers. Okay, then this one too. Okay, unrestricted function. Obviously, the domain x is an element of R. The range y is an element of R. Okay, and if I was to ask for which values of x is the function increasing, obviously x is an element of real numbers because the function is increasing everywhere for each x value. It's the same thing with this one. For which values of x is the function increasing? The function is increasing everywhere. If they were to ask you for which values of x is the function decreasing, is this function decreasing anywhere? Then you'd say the function does not decrease anywhere. So you wouldn't be able to find values of x where the function decreases. It means x has no solutions for when the function is decreasing. Same thing would apply here. And vice versa, if you had a decreasing function and they ask you for which values of x is the function increasing, obviously that means it does not decrease anyway. Okay, increase anyway. Whatever the alternative or the opposite was. Okay, I think my mind is playing mind tricks on me. Alright, okay, sounds safe and good. I think you guys got the point there with the straight line function, how to sketch it, and the other thing is how to find the equation of a straight line. Finding the equation of a straight line, guys, really shouldn't be a pain or a problem, especially when you are given 2 points or at least 1 point and a y-intercept. Okay, there shouldn't be any issues or problems there. Okay, let me look at. Okay, I don't have it. Okay, just another thing quickly. There's something that u does to the function. If, for instance, we are given the mother graph or the mother straight line, and all of a sudden this mother straight line, let's say we say to the mother straight line, we say -2. Now, if the mother straight line was y is equal to x, and all of a sudden this function changes to become y is equal to x minus 2. The question that can be asked is, what effect or what transformation led to this function becoming y is equal to x minus 2? Can someone tell me what would they say in words? If they were to say, describe in words the transformation from the mother graph to the function y is equal to x minus 2. Anyone in the comment section who would let me know, what would you say in words? What has happened to the function, to the mother graph? Explain what happened to the mother graph to become this function. Okay, maybe if you guys can answer that, then I can ask the next question. It shifts the graph from the origin, okay, to passing the y-axis at -2. Okay, I love what you said there. Okay, I love what you said there. So I love what you said there, and I agree with it. Okay, but just something that is quite straightforward and short. Remember that if this was 0, for it to become now -2 means something happened. Okay, And this Q value has to do with the effect of either shift up or shift down by a number of units. So the question then is here, this function y is equal to x, for it to have now become y is equal to x minus 2, what happened to the function? Okay, so this function, it shifted down. Why do we say down? Because there's a negative sign. Minus means shift down. It shifted down 2 units. Okay, by 2 units. The mother graph shifted down by 2 units. The mother graph shifted down by 2 units, and that's it. Okay, I know some people say it vertically translated by 2 units. Vertically translated down, or moved downward, or vertically downward. Some people tend to use other words, but at the end of the day, as long as you are able to explain the shifting or the movement of the graph downwards by how many units? By 2 units, and that's very important. Okay, it's like if I then gave you another function, y is equal to x plus 4, and then I asked you from this function to this one, what happened to the function? Y is equal to x minus 2, and now we have y is equal to x plus 4. What would you say? What happened? Describe the transformation of the function from y is equal to x minus 2 to y is equal to x plus 4. Very good orally. So it shifted up by 6 units. So these are the things that they want to check. Okay, they want to check these things. Okay, these are the things that they want to check as you progress on. Okay, can you explain the parameters? What does Q do to a function? What does the value of a do to the function? All right, that's very important. Okay, all these things are very important. If you had the mother y is equal to x, now you have y is equal to 2x. The question would be, what happened from y is equal to x to get y is equal to 2x? So if you were to describe the transformation, what happened? Okay, so what you would say here is that it increased by a factor of 2. Okay, so, and that actually refers to a vertical stretch. Okay, so it increased by a factor of 2. Okay, so it vertically stretched by increasing by a factor of 2. Vertically stretched, how? By increasing the mother graph by a factor of 2. Very important. Okay, remember this was 1, now it's 2. How? It increased by a factor of 2. Okay, very important. So if you know all those things, guys, if you know these things, you can describe the transformation of one graph to the other using words. Then you have also won another battle when it comes to functions. Okay, so finding the equation. So a few things are important as you learned them in analytical geometry. you need to know this formula. M is equal to y2 minus y1. You learned it in grade 9 as well. M is equal to y2 minus y1 over x2 minus x1. This is what we call the gradient formula. This is how you find the value of A, which is the gradient, or find the value of M, which can interchangeably be used to determine the gradient as well. Okay, we use those variables to denote our gradient. A, which is the coefficient of x, all right, that is our gradient. The value of the gradient is shown by that. Okay, so you need to know that, and you need to know that q is the y-intercept, because when you are given the y-intercept, then all you do is you substitute it in the value of q, and then you can use another point to then substitute into the actual entire equation and then solve for your A or your M. Okay, yeah, so that is very important. Okay, moving right along, let's go to the parabola, or in other words, the quadratic function. In grade 10, guys, the quadratic function was written in this form: y is equal to ax squared plus 2. And all of us should know this form: y is equal to ax squared plus 2, because this was the form that our function in grade, what grade? Grade 10, it was written in. Okay. And a few things then as well about that was the fact that our q value in grade 10 was the turning point as well as the y-intercept. That's what q denoted. This q value was the turning point, and it was also the y-intercept. A still spoke to the what? To the shape of the graph. So if A was greater than 0, we knew that it was a big smile, happy face for days, concave up. If A was less than 0, negative, so it was a huge sad face, concave down. All right, very important. So in grade 10, this is the function that you had. And that function was always symmetrical along the y-axis, always in grade 10. Symmetrical along the y-axis. So if this was minus 4, the one x-intercept, it was 4 in the other x-intercept. Okay, and what was nice about it is that maybe you would have y is equal to x squared minus 16. That basically was a representation of this function. Okay, where basically even this negative 16, like I said, it is the q value. It represents two things in the grade 10 context. It was the turning point, and it was the y-intercept, because this y-intercept also acted as a turning point. This turning point also was referred to the y-intercept, so it had a double function in that this point is the turning point. It is also the y-intercept in our grade 10 syllabus. Very, very important that you don't forget those things. Then here's another thing. In grade 10, our function, all it did, it moved up depending on the q value, or it moved down or shifted down. So vertical movement was an integral part of what our functions did. It either moved up or moved down. Okay, right on. I hope we're all sort of like getting this. This was q greater than 0, high, you're moving up. If q is less than 0, you're high, we are moving down. So all of these important things that q has an impact on basically affected the entire graph. Okay, and that's what the function forever did. And also, if a was greater than 0, then we knew that it was smile, And the more our a value increased, then that informs our stretch and our vertical stretch of the function. Okay. Whereas on the other hand, if a is between 0 and 1, it spoke to our vertical compression. Whereas if a is less than 0, then we spoke to the reflection in the x-axis. Right? Yeah, so these are important things that in grade 10. And the thing is, when you're in grade 11, you can't take for granted these things, people. All of these things, you need to know them, right? They were covered in the grade 10 context, but now you need to make sure that you still are very much in the clear as to what and how things ought to be done. Okay. Now, let's move on to grade 11. What about grade 11? Grade 11 has two forms of a parabola. We have the standard quadratic form, which is denoted by y is equal to ax squared plus bx plus c. All right. Okay, that's the standard quadratic form. And from that form, a few things that are noteworthy is the following. A greater than 0, A less than 0, A greater than 0, concave up. A less than 0, concave down. Turning point, we use this formula, x is equal to minus b over 2a to find the x coordinate. Or if two x-intercepts or two x values on same horizontal line, axis of symmetry, x is equal to x1 plus x2 over 2. So those x values that exist for horizontal lines in Cape Town, no, I'm kidding, we're not in Cape Town. Those two x values that exist on a horizontal line through your parabola horizontally, the x values that are there, we can always add them and divide it by 2 in order to find the x coordinate of the turning point. Okay, so two things in order to get the x coordinate of the turning point. If you are given this form, guys, only this form, then it means you can find the x coordinate of the turning point. To find the y coordinate, we can use 4ac minus b squared over 4a, or substitute x is equal to minus b over 2a into the function. Okay, it's really up to you how you want to best do it, or how you want to best address it. Okay, so like I said, our standard form is ax squared plus bx plus c. when a is positive or a is less than 0, a is positive, it's concave up, a is less than 0, concave down. And that's the shape. Secondly, we need to know how to get the turning point from this quadratic form. There's a formula x is equal to minus b over 2a. We use it to find the x value. Then correspondingly to that x value, you need to find the y. You can only substitute the x value into the original equation and get the y value of the turning point. Or you can write down these two formulas. When you want x, you write x is equal to minus b over 2a. If you want y, you can say 4ac minus b squared is equal over 4a. In that way, you can avoid the confusion, and in that way as well, you can be able to get the x and the y coordinate of the turning point. 3. Draw in axis of symmetry. Label it. 4. Okay, so after drawing in the axis of symmetry, dual intercept method. Okay. I think I'm gonna hold it right there for today, guys, for our functions, and unless you guys still have some petrol in the engine, then I can continue. Don't mind. Petrol in the engine, still got desires to go, or you guys wanna hold it right there? We can pick it up another evening. What do you think? Let's see in the comment section. Needs to marinate. I love that. Okay, okay, then that's fine. I don't know if you guys want to. Okay, hopefully you see what I did. Yeah. And then what I can ask as well then is to, you guys can check out just the relevant exercises to actually do on straight lines. How to sketch a function, how to find the equation. I guess I can put it up orally. Are you in the WhatsApp group that I have, or what? Or are you just playing it safe here in the platform only on YouTube? Because yeah, I guess what I can do is I can always post up. Even if it's in a post, I can post up pictures of what you guys can do for sort of like work on your own. Yeah, it's important for the knowledge to marinate. Yeah, so give yourself what WhatsApp group? Guessing you don't know about it then. No, it's fine then. That's fine. I don't know how we can do this though. Yeah, okay guys, I'll see you then another evening, but thank you so much. It was good that you could join in, and yeah, thank you. Bye Aura, bye everyone else that was here, and we'll definitely pick it up another time.